This is section 7.2, solving systems of equations using substitution and elimination. Now they'll tell you use substitution, they'll say elimination, addition. Those two are the same words. And then we're going to have a couple word problems. These ones that are straight math, you can do them by hand. I am going to show you how to do one substitution by hand, one elimination by hand, but then I'm also going to show you how to use the calculator. So what happens with substitution is, what would be ideal is to take this bottom equation and plug it in up here for x, because we want to get it down to just one variable. So I'm going to write my first equation, and then x for that second one is equal to 4y. So right here, I'm going to plug in 4y. When I do that, this equation is down to one variable, one letter. So 4y plus y is 5y. We're going to divide out the 5 to get y by itself. So y is equal to 1. So as far as the solution, we know y is equal to 1. From there, I can use either of the two equations to solve for x. So the second one just looks a little bit easier. So I want to find what x is. I know y is equal to 1. So x is equal to 4. You could also plug it into the first one. It's irrelevant which one we use. So we know our y is 1. Drop this down just a little bit. There we go. Subtract the 1. So x is equal to 4. So it doesn't matter which one you plug it in, x is equal to 4. Now I'm going to take you over to the calculator for this. So it's the same thing we did that we used in 7.1. Whenever I go over calculator steps, I'm just going to show you, I'm going to go through it slowly one time. You should take notes and write it down, or you can pause it. But after that, I'm going to move through it a little bit quicker on how to use the calculator. So again, I would pause the video for the first time I go through it, and write your notes down on how to use the calculator. So again, we're going to use menu, and then choose algebra. Solve a system of linear equations. And it was menu, algebra, solve system of linear equations. Menu, algebra, solve system of linear equations. And when this dialog box pops up, you can click OK. The easy way to move down there is just to hit your tab key. It'll turn red as I hit the keys. And then when you get down to OK, just click enter. I'm going to put in the two equations. It doesn't matter which one goes on top and which one goes on bottom. Okay. And you see that's the point we got. We got 4-1. I'm going to work the next one. I'm not going to flip back over to the note guide. So it's menu, algebra, solve a system, tab to OK, and then click enter. All right. I'll pause for a moment to let you get that put into your calculator. The best thing for you to do is to be using the calculator as we go along. If I'm moving too fast, again, you can pause this until you get everything in, and then restart the video. So these two lines cross at the point -7, 35. That's the solution. Flip over to the calculator. I'm going to put this in. And I'm going to pause for a moment and double check what I put in. I always do that. And I get 2, 9 is the solution to this one. Let's look at our next one. Where was the last one I did? 4x. Taking my time here, putting this in. Again, I'm just going to look and visually check, make sure my signs are correct. So that has a solution at 2, 7. All right, these last two, once you use elimination addition, you can still use the calculator, but just for the sake of showing you how to do this process by hand, I'm going to do this first one. All right, so with addition, what you do, addition or elimination, however you want to look at it, we want to eliminate one of the variables. So I see I have a plus y and a minus y. This isn't really well set up for elimination. So what we're going to do is I'm going to write these out. And then we're going to take them and we're going to add them together. So 7x plus 8x is going to be 15x. A negative y plus y, they end up canceling out. And then 39 plus 51, that's what, 80, 90. So we've eliminated one variable. From there, I'm going to divide out 15 twice. And I believe is a 6. What if I'm not sure? Let's do this. You can always double check yourself. 90 divided by 15 is a 6. So x is equal to 6. You don't necessarily always eliminate the y. You may eliminate the x. All right, from there, we're going to plug in the 6 to either one of the equations. I'm just picking the first one, not for any particular reason. So our x is a 6. 7 times 6 is 42. At this point, we're just solving an equation. So subtract 42 from both sides. So I bring down the negative y, and 39 minus 42, I believe, is negative 3. I'm going to divide out negative 1 so we can make y positive. So y should give me a positive 3. All right, now from there, I'm actually going to flip back over to the calculator and put this one in. I did it by hand, but maybe I'm just not feeling very confident. I just want to double check my work. Maybe I just want to skip doing it by hand altogether. Whatever you prefer. And it gave me 6.3, which is what I got. All right. So again, this last one here, which is straight computation, I'm just going to do it by hand. If anybody would like more of them work by hand, send me an email. I would be more than happy to do that for you and send it to you. If you ask for it, I'll send it to the whole class. I won't say who asked for it. So people just like to know. So that one crosses at 3, 4 real quick. always like to double check what I did. Now we move down to everybody's favorite. We love those word problems. All right, a basketball player scored 23 during one game. So that's 23 points, 23 times during one game. She scored a total of 37 points, 2 for each 2-point shot and 1 for each free throw. How many 2-point shots did she make and how many free throws? Okay. So let's look at this. Let's let X be our 2-point shots. And I'm going to let Y be our free throws. Now she actually got the ball into the basket 23 times. So whether it was a 2-point shot or a free throw, she got that ball in there a total of 23 times. So the 2-point shots are worth 2 points. So it's 2 points times however many of those she made. Plus the free throws, they were just 1 point. So it's just Y because there's an understood 1. We just don't write it in. So it's 1 point for the free throws. And the total points she scored was 37. So we have a system. Whatever you label for X and Y, write it down. I used to not write it down, and then I couldn't remember what I labeled X and what I labeled Y. And then I just had to kind of go back and figure it out. So if you just take the time to write it down, it saves you a lot of heartache in the end. Tab down. And again, if you do the X plus Y a second, it can go on the bottom. Which one's on top and which one's on bottom does not matter for system because we are just finding the point where they intersect. Okay, so they intersect, these two intersect at 14.9. So 14 is our X, 9 is our Y. So she had 14 2-point shots. And she made 9 free throws. Now they may ask you for the free throws first and then the 2-point shots. So just be careful with that in the order which they ask for the answer. Excuse me. Dave wants to purchase 17 pounds of a party mix for a total of $75. To obtain the mixture, he will mix nuts that cost $5 per pound. So X are going to be our nuts. And they are $5 per pound. LB, if you don't know, is the notation for pound. With pretzels that cost $3 per pound. So I'm going to let Y be our pretzels. And they are $3 per pound. And there's no particular reason I picked X for nuts and Y for pretzels. Generally, whatever order they show up in the word problem, that's how I assign them X and Y. All right, so X and Y represent the number of pounds of nuts and pretzels that you use. So the number of pounds of nuts plus the number of pounds of pretzels equals the total number of pounds that he wants, which is 17. Now, nuts are $5 per pound. Pretzels are $3 per pound, and he wants to spend $75. The hard part about these word problems is setting them up. Once you have them set up, you're good to go. So let's get the calculator going. Oops. So these have an X plus Y component that I found. So our solution is 12.5. 12 is X, 5 is Y. So we have 12 pounds of X, which are nuts. Let me scoot this down just a second, just a tad rather. And then Y was 5 pounds of pretzels. I believe this is the end for 7.2.